3.7 Related Rates. Look at example 1. The variable x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. They want us to find the derivative of y with respect to t when x is 1, given the derivative of x with respect to t is 2 when x is 1. Okay, so first thing we're going to do, we're going to take this equation, y equals x squared plus 3. And the first thing I'm going to do, I'm going to take the derivative of this equation with respect to t. So if I do that, I'm going to have to do implicit differentiation. Okay, the reason why I'm going to have to do implicit differentiation, and this might sound a little bit confusing, this is an implicit equation, but I'm taking the derivative here with respect to t when that's a y. Same thing here, you're taking the derivative of this variable here, which is an x, where you're taking the derivative with respect to t. So notice what I would do, I'd first take the derivative of y, which is 1, and then I'd write down dy dt equals, I'm going to take the derivative of 2x, so that's going to be 2x, and then I need to do 2x dt, again because this x is not with respect to t, and then I take the derivative of the constant constant is 0. Okay, so now I have this. The question wants us to find this, dy dt. So I have dy dt equals 2 times x. Well, they want us to figure out what dy dt is when x is 1, so I'm going to substitute 1 here, and dx dt is 2. So this would be 4. So I figured out dy dt is 4. They call it related rates because this rate here, okay, rate is another way of saying derivative, rate of change, and this rate are related to each other within this derivative equation. Alright, so let's do another one. Example 2, a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the water, of the disturbed water, changing? So here's a picture of what's happening. You're dropping a pebble into the pond and you're getting these concentric circles. Okay? So, first of all, it says the radius r of the outer ripple is increasing at a constant rate of 1 foot per second. So, anytime you have the word rate, you want to write that as a derivative. So this is saying the rate of change of the radius with respect to time equals 1 foot per second. Okay, so there's that statement. Then it says when the radius is 4 feet, at what rate is the total area of the disturbed water changing? So again, we got the rates. So this information is known as the given information. Okay, this was given to us. This next information, this is what we want to find. Okay? Because they don't give us the rate. They want us to find what rate of the total area, so what is the rate of change of the area of the water changing with respect to time when R equals 4 feet. So I got my given, I've got my final. Now I've got to come up, the first thing I have to do, I have to come up with the equation, right? Come up with an equation that relates R and A that deals with the problem. So that's what I need to do now. Okay? So if you notice here, we know that the area of a circle is equal to pi r squared. And that, what they're trying to find here is how much of the area of this circle is changing. Okay? So now, the next step, once you come up with the equation here, the next thing you're going to do, you're going to take the derivative of that equation always with respect to time. Okay? So the derivative of the area with respect to time would be derivative of area with respect to t equals, this is going to be 2 pi r, because pi is a constant, and then you would have dr dt. And now we can use this related rates, these are the rates that are related to each other, to find dA dt. So we've got 2 pi, we know r is 4, and we know dr dt is 1. So this is going to be 8 pi 8 pi, so the area would be 8 pi feet squared per second of its area.